So some of the other things I can do a Z pool, I can add. Let's just see that really quick. It's amazing. I can go Z pool, add to the pool called monkey. And I can say, add these two disks. Oh, I'm going to say a mirror of.
How many people do you know that have forgotten to put mirror and then they've really got a problem?
Oh, yeah. Isn't that all dependent on the block pointer rewrite stuff, though? No?
Like I said, as long as it's within the limited window. They're talking about this at last year's ZFS Developer Summit. Cutting edge ZFS stuff, I'm not going to be able to tell you much about until a month from now, because that's what the ZFS Developer Summit is. So, but I've been thinking about implementing wrappers just to keep people from screwing themselves with that.
So, if you want a wrapper, there's the and. The other thing is some of the GUI wrappers, like the NAppit one. I don't know if people are familiar with NAppit, but you can just add that on top of Omni to have it help you create pools, and it'll stop you from kind of doing the stupid.
And the other thing you can do to prevent the stupid is use -n first. Zpool -n, whatever, and it won't actually do it, but it will tell you what happens. Zpool -n.
It's like a dry run. I think what we've learned from this is be careful when you're adding. Okay. So let me try to do the wrong thing. So I'm going to do zpool add. Oh, look what I did too. I didn't give the full device name, so I think I already did it. Right, so yeah, it gives you, hey, you don't have both devices. Yeah, it's already in the pool. Yeah, so just make -n part of your vocabulary. Even create like an alias for zpool add. All zpool add is zpool add -n. Helpful. So yeah, we can do some other things. Let me get back into my presentation here. You did see me add to the pool, and it created, it kind of doubled in size here. And the cool part again is that it can be in flight. Let's catch up here. So I also have the ability to create block devices. So all I do is zpool create -v, capital V means volume, then give it a size of whatever, and then whatever the name I want. In the pool, and for the example here, the pool name was try, this block device named block device, whatever I want to name it. That actually ends up as a device file in the dev tree. It ends up in dev, RDSK, ZFS, and then pool name device. It becomes a zvol, yes. Yeah. Oh, it is in that path, zvol, yeah. Now, the most common use for these block devices is to share out through, and we talked a little bit about the ComStar. I can share that block device out over as a SCSI target to over fiber, over Ethernet, over whatever. So some of the other things that you can do dynamically, you can add additional disks into the pool. You can replace disks. On the command line, you just say, replace this disk with this disk. Another one, I don't have it up here. Why don't I have up here? So usually you don't have an extra disk in your pool that you can just say, hey, replace this disk with this disk. The other two commands that they have are offline and online. So what you can say is, let's say I have a 12 disk JBOD. I can say, hey, offline this disk. And for that time, ZFS won't try to write to it, and it also disconnects it from the pool. And so that you can, if you have something that's hot swappable, you can just move that drive, replace it with a new drive, and then you say online that disk, and just bring it back in, the new drive, and start resilvering at that point. We can also use attach, yeah.
In the split mirror scenario that you're talking about, does that work only if you have a single set, or can you do it split off?
You can split off anything that's more than one. So if I have a two-way mirror, I can split off, oh, I just accidentally flipped you guys all off. You can split off this. You have to do it individually, yeah. So you'd have to, if I had this mirrored pair, and this mirrored pair, I'd have to split off this disk, and this disk.
You need enough to be able to recreate the pool
On the other side. I always laugh about this. Every year I would go out to engineering and we would make our demands of engineering from the field. And I always wanted more than a three-way mirror. I just wanted a four-way mirror, right? Like having a four-way mirror is wonderful, right? I can have a four-way mirror. I can split off these two and use them somewhere else for replication purposes. So instead of a four-way mirror, they gave me a 2 to the 64th wide mirror, so I can have as many wide as I want. Right? So if I have a four-way mirror, I'm going to split them off a disk at a time.
And then do you have to stop writing while you're doing that? Because, then what happens to the writes that are in between when you split off the first disk out of one set and when you split off another disk in the second set, right? They've got two different...
They're going to have two different, they are going to have two different sets of data. Yeah, you're going to want to try to do them all at the same time then. Yes, good point. Thank you. Other questions? No? Yes? No? Okay. Some of you have quizzical looks on your face. So I talked a little bit about this idea of data corruption. So what ZFS does, typically, even if you had like a 4-wide mirror in those massively expensive enterprise SAN devices, and you read in a bad block, if there's not anything there to check the checksum and make sure that that's not bad data, then you get what's called silent data corruption. I don't know about you, but I don't like the idea of silent data corruption. I want it to be very noisy, right? Like I want to know, hello, data corruption, right? But you could have silent data corruption because most of these things will round robin, right? Like, so if there's a bad block on this disk, even in a 4-way mirror, it might pull the bad block out and might be good on the other disks. There's all kinds of things that can cause data corruption besides the one uncorrectable error in every 10 to 20 terabytes. There's also things like in-flight write errors where the file system says it wrote to block 10, but it actually wrote to 11, got changed over in the controller. I will tell you, and I'll tell you the story, the controller of choice in the ZFS community are the LSI cards. And I will tell you why the LSI cards are the best. The reason being is that they were the card of choice at Sun when ZFS first came out. And what we found was that there were a ton of errors that the cards were creating, right? Like, geez, look at these cards. You go back to the LSI guys or the QLogic guys and go, oh, look at this, Your card has just created, 10 errors just writing a 1 megabyte file. And so, good engineering is always being able to listen to the problem and make a solution. Now the LSI cards are the best, right? Because they listened, they realized what the problems they were having. So I probably wouldn't build anything without an LSI card. Now there's all kinds of, I could do another 2 hours on LSI cards and all the different LSI cards and firmware and drivers and all of that. You just want to make sure the firmware and the driver are the same. I think version 16 of the drivers or the firmware is probably your best bet for Omni. For the LSI guy, yeah. I'll tell you a trick I do. I boot FreeDOS on a little USB stick, and I use that to do my firmware revs, or do it, try to do it off platform if I can, or if I, for my systems that are in New York too, I'll do them on my systems here, and then I'll ship those out over there. So. Yeah, it's not easy to do on Illumos. So ZFS does what you want it to do. If it reads in that bad block, if it checks the checksum and the checksum is bad, it'll just go searching for a good version of that block. If it doesn't find a good version of the block, and you see this in all the email lists, people are like, oh, ZFS just told me I had corrupted data and that I should back it up or I should restore it from backup. What should I do? What you got to do then is restore it from backup. If it can't find a good block, it's going to be noisy data corruption. It's going to go, hey, you have a bad file here. I can't figure this out. I can't find a good block for you. I've tried, but I can't find one. So you're going to have to go find your backup and restore this file. And it's nice to it. It tells you the file. Right? It's like Monkey Jacob file. It's like, this is the file that's bad. Here. Go get this one. It tries. I remember an interview with I think it was Bill Moore early on too. He's like, well, what if it can't find that? What if I don't have redundancy built in? And he goes, well, it's not psychic file system. It can't go, I think the data was a 1, then a 0. It can't get out. Yeah. It caused the reads to fail. Yeah. Yeah, that would be, yeah. Yeah, my best guess. My best guess is the data in this file for your taxes was, it lets you know that it's failed. So the checksums are checked all the way down. One of the cool things about this too is that the SAN vendors actually have checksumming on the data block. But what they'll do is they'll put the checksum. Everybody knows you don't put the checksum in with the data that you're checksumming, right? Like they'll lay the checksum right on top of the physical block on disk. You can't check the checksum. What if the checksum's wrong? So in ZFS, they'll put the checksum in the higher level block. I have the word inode, I'm sorry. It's dnode, but it will actually, the block number that the data exists in, and the checksum will be saved in a different block, a different area of the disk. And it's checked all the way up, right, into the super block called the Uber block. There's 4 of those, and they all have to check to make sure that the pool is good. This is one of the reasons why ECC memory is so critical with ZFS, is that if for some reason ECC memory created, I don't know why anybody wouldn't use ECC memory. I think we want computers to be accurate, right? But ECC memory, we may take one of these top level data structures and have it be corrupted, and the corrupt block can be written out. Now, in my career, I've been using ZFS since 2004. I've probably only seen like 4 of those where the whole pool was corrupt because one of the top level data structures was bad. Again, if it's your job and you're going to get fired, be careful, get the ECC memory. On test boxes I have a ton of test platforms where I don't use ECC memory for my junk test stuff. I don't worry about it there because I don't care about the data. If for some reason this happens to you, there's like, one guy on the planet that can pull that stuff out again? I'm working on it. not there yet, but, you know, working on being able to pull a pool back together if top-level data structure is dead. So just use the good stuff. Because of two different things, mostly the transactional nature of this, and also anytime that you're reading in data, it actually looks at the checksum. If you have a lot of data at rest, you may want to go through your pool on a regular basis and check all the checksums. That process is called scrub. It can be incredibly I/O intensive, right? And it can take, if you have a big, you know, half petabyte or I wonder how long your scrub takes. Probably not that long though, because you have.
The whole thing is like different, like it's used as an MapReduce job,
Okay.
like object storage. So every time we
You read it in, yeah.
create a zone, we attach a CFS, done the job, and
So you don't run scrub on it? No, yeah.
data doesn't matter.
My friends out at University of Minnesota, they said their scrubs will take them 4 or 5 days on a half a petabyte. So scrubbing, there's all kinds of theories. You know what I find funny is that if you look out in the world, they will tell you to run scrub, like if you read blogs and stuff, they'll tell you to run scrub like every 2 weeks. I will tell you that the person who wrote that asked me at one time how often I would run scrub, and I'd be like, I don't know, every couple weeks. So I think it's kind of fun that that's part of the world out there. I will tell you, no, don't run it every 2 weeks. That's just a bad number. That's just a crazy swag. If you are reading data all the time, your data's being scrubbed all the time. So if you have a pool that has very, very active data, you want to run scrub all the time. If you have a lot of data at rest, if this is your backup, if this is stuff that you need to be solid and safe and secure, on a system like that, I might run scrub one after another. Just keep scrubbing, because that data is not being read back in again at any point. So I'd probably start the scrub, and when it finished, I'd start it again. So it really depends on your data and how active the data is. Just one more thing here on transactional design. So we have this idea of transactional design. And so when data comes in to ZFS, it kind of looks at it and says, what kind of data do I have in here? What should I do with this data? If it has data that's synchronous, right, it knows that. And it says, hey, this was sent to me synchronously. I will take care of that right away. And in the meantime, I'm going to write some log information until that data gets out to disk. I'm going to make sure I'm going to write a little bit of log information to make sure that I watch that data all the way through until it's acknowledged. In synchronous, for synchronous writes in POSIX compliance, it has to be written to stable storage before the client can be acknowledged. The fact that we write this information to a log file lets us, let the synchronous transaction continue. It's the quickest way I can say this. Because ZFS knows all this stuff, what I can do is I can shim in a little bit of SSD so that I can put that log information on that SSD device, which is a permanent device, and the acknowledgement can go back to the client. Dan was just telling me last night that they got a little bit of NVMe code out there. For this device, there's no better device than an NVMe device. Because these transactions move in and out serially, the quicker you can get one in, the better the performance of the overall system.
You want the lowest latency possible for your swap.
Would you like me to put out a call for volunteers to beta the code?
Well, I mean, it's in Illumos gate, it's in the upcoming OmniOS plugin. It will probably be most likely be in R1.16, and the NVMe code that's in the gate now is NVMe 1.0. I do not know this. I don't know if that
The devices?
devices that maps to, or whether or not it's good enough to exploit the device that may be a more advanced NVMe revision, but that code's in the gate now, so yeah.
Yeah, NVMe when it first came out was like, yeah, I don't know. I mean, the NVMe cards were, you know, multiple thousands of dollars. Now there's a little one that's like $300.
There's been code at the gate for purpose-built special driver SSD PCIe cards for at least 9 months, maybe even a year now. And I got to test those. It makes a difference.
Huge difference, yeah.
It makes a difference, but even just as a slot device.
Now you can also imagine that this is tiny. Is Zilstat in Omni? Zilstat? There's a little dtrace script called Zilstat. If it's not in there, go get it. But it'll show you how much Zil is being written at any time. Even on gigantic systems, I've only seen like hundreds of megabytes of Zil at any given time. So a small, teeny device, very low latency is what you want for that log device. I also can create cache. Now, so on read, when I read things, yeah, I'm not going to do my whole, I have this whole analogy around beer and Canada, and I won't do that, but just I'm running out of time. But so if, when you look at access time to memory versus access time to disk, it's 1,000,000 times slower to go to disk. Disk access is in milliseconds, memory access is in nanoseconds. Okay, roughly, right? 1,000,000 times though, 1,000,000 times is very, 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 very slow. So ZFS does this thing where if it goes out to disk to read some data in, it'll just leave it in memory. Right? If it took that, and I use the example of driving to Canada to get a beer, right? Like, if I'm gonna drive to Canada and get a beer, I might as well get a 6-pack, right? At least. It also does prefetch by default too. It just, you know, if I'm gonna take that long trip out there, I'm not gonna just grab the one block I need. I'm gonna grab the next couple few. So it'll bring all that stuff in. And then all of memory then becomes this giant cache. Yeah. So then the next user that comes in and wants to read that data, it's 1,000,000 times faster to access that data than the 1,000,000 times greater trip out to disk. Now I also can add additional cache out here using SSD. Now, one of the things that you should know, you can't just add unlimited cache out here, you know. I usually use a number roughly 10x memory. So if I have 8 gig of memory, I probably don't want to go more than about 80 gig, maybe 160 gig for the amount of L2 ARC that I use. The reason being is that when it takes that data out of memory and lays it into the SSDs, it has to create a table in memory to what's out there. So all of a sudden, if you add too many SSDs, what happens is that the table of what's out on the SSD starts to choke memory. So be careful with that, but we can have a little bit of additional SSD up front. There's a project right now in ZFS on Linux community that I love. It's the ability to asynchronously mirror back, like so you could have a pool full of SSDs that are back-ended by HDDs. That's HHDs. It's kind of a cool project I'm watching. That would be really fun to use. So to add those devices, just add them. So one more thing here we'll just look at with ZFS. I know I'm running out of time. I hate this. I can do a snapshot of any data set. So the command to run that is just ZFS snapshot, the name of the data set, and again, the name of the data set never has the front end slash on it. It's the pool name and then the data set within the pool. And then you have to put in an @ symbol and then some string. Whatever string you want, whatever can uniquely identify this snapshot. What happens at that point? So if the data set is try data, what happens is a new directory mapping is created underneath that try data. There's a .zfs directory that's put in, there's a directory called snapshot put in, and then the file structure that existed is put in place. So if you need to go get those files, you can just go into that directory path to go get files, read them in. Now, all snapshots are read-only by default. You can't write to them. There's this other object called a clone, and that allows me to take a snapshot and create a data set out of it. One of the guys on my team at one point in time did that with virtual machines, right? Like he took a virtual machine, then snapshot and cloned it like 100 times. And well, actually it was 1,000 times, and it was how to create 1,000 VMs in under a second. So, snapshot and clone, and use no disk space on top of it. Because what happens is the pointers are just updated to the original data. So we're just, new paths to get to the old data. Right, and I think that is my next slide. So to clone. Oh, I didn't do the send, the ZFS send and receive. And so I can run the command ZFS send, and like 5 minutes before ZFS came out into the wild, ZFS send was still called backup. It was like with ZFS, take this file system and back it up to a location. You can send it into redirect it into a file, or you can pipe it into another executable. And so once they realized that they were actually really they weren't really backing it up because the object can't be scanned like a backup and see like a table of contents and all that, they called it the word send instead. So I'm going to take this snapshot of data and I'm going to send it someplace. Where am I going to send it? I might send it to another host. I might send it to another pool. I might send it, wherever I want. Now the thing catching it though, to lay it back out into a ZFS file system is the ZFS receive has to take that data stream and then write it back into a file system at that other location. So you can write it into this big binary object and then receive it back in again to put it back onto disk. You also can do snapshot incrementals, and I think I already said this, that if I have a data set, and this is so cool, especially for if you have large files. In traditional rsync world, if I have a large file and I make one block change, I have to, and if the timestamp has changed, I have to copy that whole file in my backup again, right? The whole thing. With ZFS, if I have this snapshot and I have this snapshot, it can actually compare the two and see the block level differences between the two and just send out just those blocks. So, very, very powerful tool. You can also export and import. So now that I'm down to about, what do I have left here? 15. I have 15 minutes left, I'm sorry. So now that we're down to about 15 minutes, I'm going to go much quicker over the package management and services than I wanted to. Package management, I would say the package management, the image packaging system kind of came late to the party. A lot of people have already done different package management. If anybody ever did System 5 packaging, you hated it, I'm sure, yes. There was no dependency mapping, there was no anything. I would say from all my years at Sun had a tendency to over-engineer everything, and they did the same thing with IPS, the image packaging system. Some of the stuff that you can do with image packaging is just overwhelming, right? Like I can do things like freeze a level of a package, or I can have multiple versions of the same package on the same box, but say use this one. So it is dramatically over-designed. And it's everyday usage. It's package, install, name of the package. It's very, very simple. Now, one of the cool things about it, though, in using it with a ZFS-rooted environment, is that we have this tool that's kind of integrated into packaging, upgrading, and boot, called the BE-admin command. That stands for Boot Environment Administration Command. So if I do BE-admin, create, and then give it a name, it'll actually take a snapshot and a clone of my root environment. And then what it'll do with that clone is it'll add new packages to it. And it will just be like the block level differentials between this one and this one. So I can potentially have hundreds of boot environments on a, I don't know, 4 gig memory stick or something. Maybe not. Okay.
Grub is horrible. The grub that's used in all of those distros is horrible. There's an upper limit to how many BEs you can have before grub pukes on them.
Which is what?
40, yeah.
40 is still plenty, yeah. But the key to this is that it will just do the block level incremental differences between the different things. And I can cram all of that into very small boot environments. Now, all the packaging tools that you will use with Omni are all very aware of that, right? So if you do an update and it sees that you need an alternate boot environment, it'll just automatically create that for you. Otherwise, it'll just add the packages in. The whole idea of the packages kind of layering on top of each other was this image management system. Very cool. But it does that snapshot and clone. Open Indiana. So with the package command, you can do things like list the current packages that are on the system. You can get information about the packages on the system. You can search. And you have the ability to have multiple, what they call repositories or places that hold packages. So you can just say, start here, then go there, then go here, then go here to get your packages. So you can have it search, and then you can have an install, right? That's usually what you want to do. Package, install, package name. You can also do an uninstall of a single package. The whole idea of it was that it's very modular, and then also one of the things that we didn't have with System 5 packaging is dependency mapping, right? Like if this package needed this, you didn't know about that. You had to read about that, someplace, hopefully. And a lot of times it was undocumented too, so that was sad. If you want to go out to OmniTI's package repository, they have a catalog out there that shows you a list of all the packages that are available. Again, it's designed to be a very minimal install, and then you pull in things as you need them. So I'm trying to think of something that's storage server. I wish storage server was in the base install. So I go package install, it'll tell me during the package installation. For this particular one, I was doing iSCSI target, it'll say the number of packages that will install for this kind of meta package. And then if it's going to update the services at all, it'll tell you that. In this example, create a boot environment, it says no. It's not going to create an alternate boot environment for this, so I can install this without taking a reboot. It also will tell you the progress, and then it'll show you all of the things that it's doing as it's installing that package. Yeah. I can't remember. So it takes a snapshot of it, not a clone.
Environment dash backup dash however many there are.
You can override that on the command line.
Yeah, it's an image setting. You can have those be created or not.
So if you're putting a drop, you have to periodically go in and prune those.
Yes.
Or you can do BE app destroy from the Illumos command line.
You have
Yes.
turned down, yeah.
It only creates an about for major upgrades. If you just add one package, you won't.
Actually, if you add one package, it creates an active BE. That was a design choice made to be conservative.
It's only if it actually is going to change anything that's already there. It's a new package that's never been installed, there's no backup.
Oh, yeah.
Right, exactly.
And again, to me, this topic is kind of almost like the sync versus async. Let the people who do the package management, they write that into the package itself. Overriding it, if you live right next door to Dan, then maybe, but I would trust Dan, right? Like I would trust him to do the right thing with the packages, and those are packaged on the package settings. So if you do a package update, I was hoping to run one of these. I don't think I have time.
No, you got really easy. Well, you're right, modular was a quick network, sorry.
I can update an individual system, or I actually can create an alternate boot environment and run like a dry run on it to see what's going to come into it for either install or update. I can, see, okay, how long is this going to take? How many packages are going to have to be downloaded? Especially in here, the network connection is not great, so I might want to run update minus NV will give me a dry run. Give me some idea of what's going to be involved in that. I do like to do that on occasion too, just to see how much, is it going to create a BE or not? Am I going to have to take a reboot or not? So you also can run the BE admin command and create your own. I will tell you, I use BE admin command all the time. I ran a lot of benchmarks. So I would do a BE admin, create an alternate boot environment. I would boot into it. I would do all my tweaking and tuning and whatever, and I would go, okay, that didn't work. And then so I'd go back to the original, create another alternate boot environment. So it's really a good way to test. Or to do without having to reinstall every time that you're done. So the boot environments are, they're always going to be on rpool. I think you can create it without rpool, but that's one of those jobs. So if I do a BA admin list, I can see all of the different boot environments that are out there. You'll actually see those boot environments out here as being data sets out there. So you can potentially mount those to a different mount point and go in there and edit them and make changes to them manually. So they're easily available data sets. We also can set publishers. So the publishers are the different repositories that we may want to scan through. And the next couple of pages of this are if you want to create your own repo. That's really a good idea, especially if you're like my one customer that has 400 open Indiana boxes. You might want to pull just having a repo here instead of having all 400 of them going out and getting stuff. You can go through and create your own repo. In the slides. So, services, what do I got? Get 6 minutes. 6 minutes to do services. I can do services in 6 minutes. So all of the System 5 derived operating systems all have this thing called the init tab file. And for years and years and years, what it would do is go through the init tab file and figure out how to boot a system. And everything in that and everything during boot was all done serially. People want systems to come up faster, right? Like I was working with a system that had a terabyte of memory on it. It took an hour and a half to boot that system. That's just unacceptable. You can't, those kind of systems don't get rebooted anyways, but doing all of this stuff in serial in modern day doesn't make sense. So when they built the service management framework, some of the problems that they were trying to solve for was mostly this, running all of these scripts in serial, especially if, like on Solaris 10, I can't even remember, Solaris 9, how many scripts there were. There was like 50 of them. And each one of them, would run, and then once it was completed, then it would get to the next one. And it might be something like, I use the example of PPP, it's like, we're starting up PPP now, and does anybody even remember what PPP is? Oh, yeah. UUCP? Yeah. So, it's starting up this stuff that you're probably not even going to use. So the problems with services was that you had this massively serial boot process, and it took a long time, and the dependencies weren't always there, too. Right? Like, you hope that the script that was running knew its own dependencies. In services, hopefully that's my next page here. So in services, I like to say they were kind of late coming to the party. Everybody else has some sort of service management framework. If you look at AIX, you look at actually that's one of my least favorite parts of the Linux community now is how fragmented it is. One does it this way, one does it that way. They're all called Linux, you get confused. But different ways to start services. The majority of them still go through that process. I can't believe I'm gonna say this out loud, but Windows has this thing called the registry, right? Like, and it, it's got like this little database of what's turned on now. So coming late to any party, you can already see what everybody's wearing, right, in the party, and you can look for the problems that might exist in those things. Putting all these services in a database, people don't like databases. Why? Why don't people like databases? They get corrupted, right? And then the other thing is that they're usually really cryptic to get into because you have to know all these different commands. So, services, it uses a database. One of the things that it does with that database, though, is it keeps like 1 billion copies of that database. So that if at any point in time the database becomes corrupted, you can import in a new database or an older version of the database and get up and running. It's a teeny tiny little database. It's a teeny tiny little database that tells you, like, is Telnet running? Right? It's not something that has massive changes and fluctuations in it. The chances of it getting corrupted are pretty slim. The commands to get in and out of that database are still a little bit cryptic. We actually have 2 commands. We have service prop, which will show us the properties of the service so that we can read in information about how that service runs. And we have service config that lets us make manipulations to the way that the service runs. But everything comes out of that database. If you have booted for the first time on and then the other thing is, how does it manage change? Right? The first time that an Omnibox boots, you will watch it load in what it calls service descriptions. And what that is it pulls in these manifest files into the database the first time. So the database not only has multiple copies of it, it also can be populated by files. So if you need to, you can just throw out the database and you can have it repopulate those the default service descriptions. Now, the other thing that services do is that they all know what they need. So if a service is dependent on something else, we try to run as many services at boot time in parallel as possible, but every service as an object knows its dependencies. So, like, it's not going to start SSH until the network service is up, right? That's a dependency. Make sure that comes up before SSH comes up. So, best of breed from other platforms, avoid the problems of all other platforms, and increase overall boot time. ZFS as a boot device, because you don't have to run FSCK too, increases boot time dramatically, multiple X. So boot scripts are run in parallel instead of in serial. They all have knowledge. I actually saw the dependency map one time. That was a thing of beauty. It actually looked like a brain with all the tentacles. I should have taken a picture of that. Every service knows its dependency. If you're going to build your own service, you can say, my service is dependent on these things. So when they were starting to build the framework too for populating these services, they built all these files in XML just because it was kind of the most dynamic language at the time, so that they could populate the database with all of these XML files. So every service has a dependency map. We can run as many of them as parallel, make sure all the information is in the database, make sure that the database is resilient to failure by having multiple copies of it and always being able to go back in time. build the XML so that they can be, build the XML too so they can be queried by outside management frameworks. So just to look at services, you can just services minus A will show you all of the services running on your box right now. It'll show you if they're disabled or enabled, if they're online, if they're offline. Probably the most important services command you'll learn though, with like less than a minute left for me in this presentation, is that services minus X is great because it'll show you anything that didn't work or didn't start. I guarantee you will lose, you will like services minus X. You also can do a long listing of a service, so you can do services minus L like SSH, and it'll show you all of the files that it needs. It'll show you all of the dependencies that it has, other services that have to be turned on, and any files that it requires to run.
I use a utility called Manifold to create new XMLs.
Oh, really?
Yeah.
You use what?
Manifold
Manifold? Okay.
creates new XMLs. It's just an answering question answer kind of a prompting.
Sweet.
Dependent can create XML, new import it.
Nice.
I don't like XML.
So, if you're a system administrator, this is the stuff you want to know. Like, where is this stuff? All of the default scripts, these things called manifests, and no, not the manifests, all the default scripts, all your boot scripts, all the stuff that you may be used to looking at an RC script, they're all in libservice. And they're kind of organized by type. There's stuff that will run at different run levels. There's network services. So there's little directories in there that you can find those boot scripts. If you want to modify them, you're supposed to move them over to Etsy service if you want to modify them. I have modified them 100 times in libservice. So I don't know, works for me. The databases are all in Etsy service. You can see if after you've run your box for a while, if you go into Etsy services, you will see 20 copies of the database. It keeps last modified, known good, first initial, so that you can go back in and import an older version of the data set or the database. Now in var service, actually my favorite directory is var service log. As a Solaris administrator for years and years and years, the log files for all of the services went wherever they wanted, right? Like they just like, oh, the printer log's over here and this log is over there. And they've taken all of the services on the box and put all their logs in one place. So you can just grep in there and find, you know, if you get error on whatever, just grep in the logs, all in one place. There's also in var service the manifest, and the manifest is the thing that is all the dependency mapping, right? And then what executable you'll execute.
When you do Illumos, post-warrant articles, the minus capital L flag will give you the path to the log file for a given service, so you can
Nice.
grep backtick SVCS minus capital L service backtick, and you don't have to go copy and paste the output of other commands. It does it for you. It's so simple to command, simple to change, but it's really effective. Wherever the services official log file is now, some services do other log files elsewhere, but the SMF one is available just with minus capital L.
Okay. Yeah, Dan will be here all day. Feel free to talk about all these different ways. If you don't like this stuff and you don't want to use it, you don't have to. You can put in RC scripts. They will run, you know. I was telling people before we started today, I had a customer who ripped this whole thing out and rebuilt all the RC scripts because they didn't like it.
Can I just use run it?
I don't know run it.
Okay.
So you can, yeah. Might be able to build a service around it. So I'm not going to talk about that. I'm not going to talk about that. Hopefully I gave you. There's also all the inetd services are wrapped in a service. So if you're used to putting stuff in the inetd.conf file, you can run this inet convert and it will go into that and wrap them up as services. So that's also a nice, really quick way to create a service, is just put it in the inetd.conf file and run inet convert, and it'll wrap it up in a server. So the commands: services, service admin, restart a service, we'll have it reread its config file, enable, disable, turn it on, turn it off. Reload is restart, yep. Service prop is kind of interesting because you can say service prop, the properties of a service, and see all of the things that are modifiable in that service. And then service config allows you to modify those properties of the service. Manifests are loaded at first boot. Services startd, actually, so another thing that's very cool about services is that they will automatically restart. If they check in with the services startd daemon, they're given a contract so that if you kill that, it'll actually pop back up again. It's kind of annoying, but it's also nice, right? Like if you have a service out there that dies on a regular basis and you want to make sure it's always up and operational, you can give it a contract to services startd and it will automatically restart it if it dies. That is the shortest version of services I've ever done. If you have the slides, there's a lot of additional material here. There's also labs. Again, if you're late here today, this was an 8-hour class that I turned into a 3-hour class. I don't know how I did, but I want to thank you all for coming. I think lunch is... it's not something smelly, so I can't smell, but it's right next door. So thanks for coming. And if you have any questions, too bad I didn't do the dtray stuff. I love my dtray stuff, but there. If you have any questions, any day, any time, write me email. I've been giving out my email address for 15 years. Nobody writes.